Okay, so we found an antiderivative kind of informally up to this point, and we noted that in our last examples when we said something like if we know that dy dx was equal to x to the fourth, then we were able to find a function y equal to 1/5 x to the fifth plus some constant as the function that would result in dy dx. Well, let's treat it a little bit more formally, and the notation goes like this. If we say that dy dx equals some function f of x, and that's our differential equation, we can express this equation in something called a differential form. And in the differential form, we isolate dy dx to dy to one side of the equation and say, well, this is the same thing as dy dx equals x to the fourth times dx. And so we want to look for some operation. We call this operation antidifferentiation, and it's referred to sometimes as an indefinite integral or the indefinite integration. And we denote it using an integral sign which looks like this elongated S. We'll talk about why that elongated S is important in a few units down the line right here. But for our purposes, we could say, well, then what would happen is in this formal definition, y would equal the indefinite integral of x to the fourth times dx. And our result right here is that y is equal to 1/5 x to the fifth plus c, where we have that constant of integration. And in general, the solution to an antiderivative is such that if y is equal to the antiderivative of f of x dx, then the antiderivative, capital F of x, plus a constant is referred to as the antiderivative of f with respect to x. Perhaps stated another way, we might also think that it would be the kind of result where if I took the derivative of this antiderivative f of x dx, it would just result in f of x. In other words, we can undo that antiderivative with the derivative and just result with that function f of x. Right? One rule that we've actually been illustrating all along here is this. We say that if we have a differential equation of the form where dy dx is equal to x to the n, then the general solution of the antiderivative of x to the n dx would be 1 over n plus 1 times x to the n plus 1 power c, as long as we make sure that n is not equal to negative 1. If it is, we've got a little bit of a different problem, which we'll explore later. So we could do this for any real value n. Let's try out the rule right here. Let's say we're asked to evaluate the antiderivative, the indefinite integral of x to the 2/3 power dx. What would that mean? Well, in this case, our solution is going to be as follows. We're letting n, the exponent, be 2/3, so our result will look like 1 over the exponent of 2/3 plus 1 times x raised to the 2/3 plus 1 plus our constant of integration c. So now all that would remain is for us to simplify this expression down a little bit. We'll note that 1 over 2/3 plus 1 over 2/3 plus 1 is equal to 1 over 2/3 plus 3/3, which is to say the same thing as 1 over 5/3, and that's 3/5. I always take my fraction work off to the side when I do this. And so my antiderivative of x to the 2/3 dx is going to be 3/5 of x raised to the 5/3 plus our constant of integration c. And that's how we would express our solution.